Welcome to a lesson with Dr. Powell. Let's talk about a technique that we can use for adding up the terms of a geometric sequence quickly. Now remember, in a geometric sequence, to go from term to term, you multiply by the same thing. In this case, we're multiplying by 2 to get from one term to the next, and we're adding them. And we're going from this term to that term. Let's talk about a way that we can quickly add this up. Now, it's a little different than the way that we would for an arithmetic or a linear type sequence. Let's think about this for a minute. First of all, notice that to get from this term to this term, you multiply by 2, then you multiply by 2 again. In other words, 5 is actually a factor of every single term here. The first term is a factor of all the other terms. We could factor 5 out of all the terms. We're left with a 1 here, plus 2, because we multiplied that by 2 to get to that term. And then we multiplied this by 2 twice to get to this one, 2 squared, and so forth. And we had to multiply 5 by 2 3 times to get to that term, and 4 and 5. See this? It's 1 plus 2 squared plus 2 cubed plus 2 to the 4th plus 2 to the 5th. This looks a lot like a polynomial, except instead of x, we had 2. Well, let's put x back in. 1 plus x squared plus x cubed. So think of this as a polynomial where we've plugged in 2. Okay, so we have 5 times a polynomial where x is going to be equal to 2. All right. Now what do we do? Well, this polynomial, 1 plus x squared plus x cubed plus x to the 4th plus x to the 5th, actually is the result of a polynomial division. Here's an example. Or actually, let's work through it and actually see how that might work. All right. So I'm going to put a 1 here. Put a line right here, and I want to put let's do a 1 and then do a 0, 0, 0, 0. Let's think about this. So let's see, this is to the 5th power. 6, 5, 4, 3, 2, 1, and I'm going to put a -1. Let's do a little synthetic division. 1, 1. Look at the result of this synthetic division. You notice you're going to just get 1s. Hey, that's like this polynomial right here. And sure enough, it is. But it's designed with a -1 on the end, and see what that does. It gives us a 0 so that we get this out. Notice that this is x to the 5th plus x to the 4th plus x cubed plus x squared plus x plus 1. So I kind of engineered a synthetic division so that the division process would yield this. All right, so what does that mean? This means this is the quotient, and since there's no remainder, that quotient is exactly equal to the dividend, what we're dividing into. So x, which is actually x to the 6 minus 1, divided by x minus 1. So you have to change the sign of that to get the divisor, x minus 1. Whew. So this whole thing can be written like this. Keep in mind, you see this 6? This 6 is actually equal to the number of terms present. So you have 1, 2, 3, 4, 5, 6. It's like you have a power of 1 through 5, but then you have to add on that 0 even, if you will, if you think of that as x to the 0. So we have 6 terms. So this guy right here is just the number of terms. This x is the common ratio number, r, in our case, it's 2, the number that we're multiplying to go from term to term, and it occurs here and here. So let's see how we can use that to find the sum. We could say this sum is equal to 5 times, and then we replace this polynomial right here by this quotient with a 2 plugged in. 2 to the 6 minus 1, all over 2 minus 1. 2 minus 1 is just 1. And let's see, 2 to the 6 is 64, minus 1, 63. So really, this is just 5 times 63, which is should be 315. And that's the sum. Thanks for watching.